Welcome back. In this video, we're going to start exploring the concept of the integral. The integral is the inverse operation to the derivative. And so the first thing we have to start with is learning all these antiderivatives. The better you know derivatives, the easier antiderivatives are going to be because we're just going the opposite way around. So in these problems, what you're going to be given is you're going to be given this S-shaped symbol right here. That means integration. You're going to be given a function, an equation right here. This is called your integrand. When you integrate that, you take the antiderivative, and then you have to add an arbitrary constant because this family of functions is only going to be different by the constant value. So if you were to take the derivative of this antiderivative, you would end up back at this integrand, and that's what all of this notation means. We have a bunch of rules of antidifferentiation that you're going to have to learn. The first one is just our power rule. It's our base rule. So if you have a constant times x to the r power dx, that constant comes out front, you add 1 to the power, divide by the new power, and then don't forget to add the value of c. You've got to add 1 to the power instead of subtracting it because when we took the derivative, you subtracted it. So when I integrate 2x plus 3, I can do each piece of this individually. This is 2x to the first power, so the antiderivative is going to be 2x squared divided by 2, and then it's going to be, this is 3x to the 0 power. It becomes 3x divided by 1, and then you add the c value. And obviously, we just simplify that to be x squared plus 3x plus c. If you were to take the derivative, this x squared plus 3x is the antiderivative of this. If you were to take the derivative of x squared plus 3x, you should end up back at this integrand. All of these values, like x squared plus 3x is the family of functions. It only differs from every other function that's x squared plus 3x by this constant value, and that's why that arbitrary constant is there. We're going to learn about solving for that arbitrary constant later on in the class, so they're called differential equations. We also have all the basic trig rules that you need to know. So like, for instance, the antiderivative of cosine is sine. Why? Because the derivative of sine is cosine. Same thing here. This is going to be negative because the derivative of cosine is negative sine. So the antiderivative of sine is negative cosine. Antiderivative of secant squared is tangent because the derivative of tangent is secant squared. Antiderivative of cosecant squared is negative cotangent because the derivative of negative cotangent is cosecant squared. Antiderivative of secant of x times tangent of x is secant of x because the derivative of secant of x is secant times tangent. And then finally, the antiderivative of cosecant times cotangent is negative cosecant because the derivative of negative cosecant is cosecant times cotangent. An example of that, and a little bit of the trig, we end up having to simplify. So like 1 over cosine times cotangent, we're going to rewrite that first as 1 over cosine is secant times 1 over cotangent is tangent. A little bit of trig simplifying in this. Now that antiderivative is just secant of x. And then finally in this first video, we have a couple of special theorems that says that if you integrate the derivative, like this is what these are doing is we're drawing connection between their inverse operations. So if you integrate the derivative of this integrand, you just have the integrand and you have to add the constant because you're integrating second. So you take the derivative of this first and then take the antiderivative, and that's why you got to add the c value. If you switch the order, we integrate this first, and then we take the derivative. The c drops out because you're taking the derivative of a constant, which is just 0. So you're just left with the integrand. So order is going to be important. This, again, is going to be a concept that we come back to later in this unit. It'll be a little bit clearer for you then. You'll understand a little bit better. Over here, I'm just giving an example of this. I take the derivative of this integral. Okay, I'm not even going to take the antiderivative. This is just going to be the integrand, x squared. I don't need to add the constant because I'm taking the derivative second. All right, we'll clarify in class any misunderstandings you might have. We'll see you soon.